Hi, this is John again. This is my Lab 18 of the TI-RSLK, the Robotic System Learning Kit, the road test I'm doing for element 14. And in this lab, what they have you doing is to create a FIFO queue that's used with the UART. So you can send and receive messages and then save it in a queue so it gets queued up and you don't lose data. This is, I guess, could be utilized somewhere down the point, especially when you're doing some information with the encoders. You can save that information. They had other examples for memory as well. Here they gave you basically a framework again with the FIFO, and then I just created some uh, some variables and a FIFO queue based on some examples that I've seen. And then they have a histogram that you can use to test that out to see if the values are being saved there. And what this is used for, it's used in the UART, and you can see where it's going to get enabled here. They do both the receive and the transmit, and then they use the queues for get and put, whether they get the information or put it. That's whether it's receiving or transmitting or whichever it's going to do. So this is a Lab 18. So what they've done, there's some examples here that you can use. They have an example for testing the FIFO. So once you code it, you can test it to make sure it's working properly, and then they have some example code that you can use to test that. Um, and again, what you end up having to do, you have to use the debugger to make sure the right data is getting sent properly, and you can walk through it and then check that. So as you get further down, they end up starting to use the UART to send out messages. So you can connect the USB and then bring up some COM port in order to view that. I'm using PuTTY, so we'll see that later. And then they go further down with example 4, where they start showing a heading, and then they start asking you, uh, there's a prompt to input data, and then they show that, and then to input a decimal, and then for hex, just to show you the processing of that. That's just to make sure really that your FIFO queue is working properly. And what's been common with these labs for a good part of them is that a lot of the labs are dependent on previous labs. So if you hadn't done the work on a previous lab, then you might have difficulty with a lab ahead, further down the road. So like in this particular one, they're using the bump. Oh, I didn't mean to bring that up. And then the clock. This is already done, the FIFO, the motor stuff. I had my own motor movement to map out for this example, the PWM. So all these things are done, the timer A1, these are all done in previous labs. So if you hadn't done those, then you would have difficulty trying to complete this one, for example. Um, and so going further, go back up. So there's an example in the lab for entering through the UART, through the COM port, a command, and then running a function. These are based on function pointers, based on a struct that they have. So they had an example of a struct. You have a command name and then a function pointer. And so I just created these functions here, which are going to be utilized for this. And then they're all mapped out in this particular table. The one thing to note, in the lab document, there are some errors. The right has do fast, so they got to repeat. So I just need to change that to that. And they're missing a comma here between sensor and go sensor. So if you compile this, you'll get an error. That's because the comma's missing. So that's kind of an outline of what's here. And again, the motor movement, so I've done that. And then the motor and that. So what I have, let me go bring up my PuTTY instance here. So I have PuTTY running, I have it connected. Oh, the other thing I did, not sure if you could see it, but I've taken the jumpers off that go between the debugger and the MSP432, the jumpers for the transmit and receive of the UART, so the UART isn't going out the USB. So I have this handy dandy, let's see if I can get it over here, this prop plug, which comes from Parallax, which I already had. So it's a USB to serial interface, and so I'm using that That way I don't plug the USB cable when I'm trying to power this up with the batteries and stuff. So if I bring this up, let me go flip the switch on, and then you see the UART came up with the message. So I just kind of borrowed some of the stuff they already did and then added some prompts, and then you have an end string. So if I type in go, then the motors will start spinning. If I type stop, they'll stop. I can go left, I can go right, I can go back, and they'll stop. So all this is using that FIFO queue and then the UART. So it's receiving these commands in, and then it's processing it through the FIFO, and then back out to the UART, or processing it into the MSP432 for the commands. And that's what you saw with the function pointers through here. So if a stop command is entered, then it performs this function here. So it does a do stop, which is a do stop function, which is motor stop. And then I just parse through this table. So when I receive something in through the UART, I check here, I do a compare on that, and then if I get a match, then I just run the function that's set for that particular for that command, and then you're able to do that. So that's pretty much it for Lab 18. It's not completely difficult. It gets some information about the FIFO queue and understanding how to set that up. That took a little bit, but there wasn't much else really to do with that, because most of the other stuff was already coded. Especially if you've done the previous labs, then a lot of that other stuff with the PWM and the motor and stuff like that should have been done already. So that's it, and now we get to move on to Lab 19, which is the BLE.